AC circuit containing only a capacitor. Here circuit shown, this is capacitor. This is supplied voltage, which is given by E equal to E0 sine omega t. At any instant, the potential difference across the capacitor plates are equal to applied voltage. So we can say V equal to E equal to E0 sine omega t, but Q equal to CV, or V equal to Q upon C. So we write here Q upon C equal to E0 sine omega t, or Q equal to C E0 sine omega t. And we know that dq upon dt is equal to I. So I equal to, we differentiate it. So C E0, and this will give omega cos omega t. This can be written as E0 divided by 1 upon omega c times cos omega t. So this can be written as I0, and cos can be converted to sine by putting pi by 2. So cos, we write it sine omega t plus pi by 2, and here we have assumed 1 upon omega c as Xc capacitive reactance. Clearly, equation of voltage is V equal to or E equal to E0 sine omega t, and here that of current is I equal to I0 sine omega t plus pi by 2. It means current leads voltage by pi by 2. Here it is shown current is starting from here. Here it is attaining peak value, whereas voltage is 0. And when current becomes 0, voltage attains its peak value. So this is line which represents voltage, and this line represents, or this graph represents current. And this is phasor diagram in which this is voltage and this is current. So current is leading by phase angle of 90 degree to the voltage, and this angle is omega t. This is x-axis. Now, capacitive reactance X equal to 1 upon omega c, which is equal to 1 upon 2 pi fc. Question number 1. Find capacitive reactance in the adjacent circuit. Here we are given C equal to 0.11 microfarad and V equal to 200 sine 1000 omega t. So we can evaluate it. So formula is Xc equal to 1 upon omega c, or 1 upon 2 pi fc. But here, from here, if we compare the equation V equal to V0 sine omega t, so we get omega as 1000 pi. So we don't need to write 2 pi f. Instead, omega c will serve the purpose. So 1 upon 1000 pi times c. C is 0.11 into 10 to the power minus 6. So this will become 10 power 4 divided by 1000 pi into 11. So we can simplify it further. So it will become 1, 2, 3, 4 zeros times 7 divided by 1000 multiplied by 22 multiplied by 11. So it will become, sorry, here this is 0.11 into 10 power minus 6. So this power, when this becomes 11, then power will increase by 2. So it will become 10 power minus 8. So it should have been 10 power 8. So instead of writing this, I must have written it as 10 power 8 into 7. And if we evaluate it, we will get 3142 ohm. Let's go to next question. Next question is, a 15 microfarad capacitor is connected to 220 volt 50 hertz source. Find the capacitive reactance and RMS current. What will happen to capacitive reactance and current if frequency is doubled? So here we are given the information C equal to 15 into 10 to the power minus 6 farad, and VRMS is given as 220 volt. Frequency is given as 50 hertz. Now we find Xc 1 upon 2 pi Fc. We put the values 1 upon 2 pi multiplied by 50 into capacitance 15 into 10 to the power minus 6. So we can take this 10 power minus 6 to numerator. So it will become 10 power 6 means 1, 2, 3, 4, 5, 6 divided by 100 pi into 50. So if we simplify, we will get 212 ohm. Now IRMS will be equal to VRMS divided by XC. VRMS is 220 divided by XC is 212. So if we simplify, we will get 1.04 ampere. Now peak value of current can be found by I0 equal to IRMS multiplied by root 2. So 1.04 multiplied by root 2. So it will give 1.47 ampere. And second part, what will happen to capacitive reactance and current if frequency is doubled? So from here, Xc equal to 1 upon 2 pi Fc. It is clear that Xc is proportional to 1 upon F. Means if frequency is doubled, Xc will get halved and then current will get doubled. Next question, a 200 millihenry pure inductor and 5 microfarad pure capacitor are connected one by one across a sinusoidal AC voltage source V equal to 70.7 sine 1000 T volt. Obtain the expression for the current in each case. So here we are given V0 equals 70.7 volt and omega is given as 1000 and L equal to 200 into 10 power minus 3 Henry and C equal to 5 into 10 to the power minus 6 farad. So let's find out peak current I0 equal to V0. This is first case when we are considering inductor. V0 divided by XL. So it will be V0 divided by omega L. Omega V0 is 70.7 divided by omega. Omega is 1000 and multiplied by L is 200 into 10 power minus 3. So if we simplify, we will get 0.353 ampere. So we can write current equation for inductor as I equal to I0 sine omega t minus pi by 2. If you remember, I've told you that current lags voltage by pi by 2. So we put the values. So I equal to I0 is 0.353 sine omega t means 1000 t minus pi by 2. Now we consider capacitance. So I0 will be equal to V0 divided by XC. So V0 XC is 1 upon omega C, that is omega C times V0. So omega is 1000 into capacitance is 5 into 10 to the power minus 6 into V0 is 70.7. If we simplify, we will get same value 0.353 ampere. Now we write current equation I equal to I0 sine omega t plus pi by 2. If you remember, current leads voltage by pi by 2. So I equal to 0.353 times sine 1000 t plus pi by 2. Let's see next question. A capacitor has capacitance 1 upon pi microfarad. C is given 1 upon pi into 10 to the power minus 6 farad. We have to find out capacitive reactance in two cases. One frequency is 50 hertz and 10 hertz. So Xc 1 upon 2 pi Fc. We put the values 1 upon 2 pi into frequency is 50 into C is 1 upon pi into 10 to the power minus 6. Pi will cancel out and this will become 100. So it will become 1 upon 10 to the power minus 4, which will give 10 power 4 hertz. Second case, Xc when frequency is 10 hertz, 1 upon 2 pi into 10 into C is 1 upon pi 10 to the power minus 6. So pi will cancel out and then this will become 1 upon 2 and this 10 will reduce the power of 6 by 1. So 10 power 5. So 0.5 into 10 to the power 5 hertz. So sorry, we are evaluating not frequency but capacitive reactance. So it will be in ohm. This will also be in ohm. And a capacitor has a reactance of 100 ohm at 50 hertz. So Xc1 is 100 when frequency is given as 50 hertz and reactance Xc2 is to be found when frequency equal to 125 hertz. So formula of reactance is Xc equal to 1 upon 2 pi Fc. So if we write it Xc1 divided by Xc2, so what do we get? 1 upon 2 pi F1 C multiplied by 1 upon 2 pi F2 C. So clearly C 2 pi will cancel out. So F2 upon F1 will be left. So it will become F2 upon F1 and F2 is 125 and F1 is 50. So 25 5s are 25 2s are. So it will be 2.5 is to 1. That is our answer. Thank you for watching.